Astronomers use the Big Bang to explain how the universe began. Georges Lemaître, an astronomer, had a brilliant idea in 1927. He said that the universe began as a single point a very long time ago. He said that the universe stretched and expanded to become as large as it's now, and that it may continue to stretch. Only 2 years later, an astronomer called Edwin Hubble observed other galaxies traveling away from us. And that isn't all. The galaxies farthest away were moving faster than those closer to us. This meant that the universe was still growing, as Lemaître predicted. If things were moving apart, it suggested that not long ago, everything was close together. Everything we see in our universe today, stars, planets, comets, and asteroids, didn't exist at the start. How did they get there? When the universe first began, it was nothing more than hot, tiny particles intermingled with light and energy. Nothing resembled what we see now. It cooled down as everything expanded and took up more space. The tiny particles congregated, and they created atoms. The atoms then clustered together. Atoms joined together throughout time to build stars and galaxies. Bigger atoms and groups of atoms were produced by the first stars. As a result, more stars were born. At the same time, galaxies were crashing and merging. As new stars were created and destroyed, asteroids, comets, planets, and black holes were produced. That's pretty much how the universe got started. Some refer to it as the Big Bang since it became so large and resulted in such wonderful things. The Big Bang itself is not visible to us. We can see the heat that existed approximately 380,000 years after the universe began expanding 13.8 billion years ago. This heat covers the entire sky and fills the entire universe. Actually, it still does. The scientists were able to map it using satellites created by NASA and the European Space Agency or ESA, such as the Cosmic Background Explorer or COBE, the Wilkinson Microwave Anisotropy Probe or WMAP, and Planck. The universe was extraordinarily smooth at this point, with only minor temperature fluctuations. The James Webb Space Telescope or JWST is a space telescope primarily developed for infrared astronomy. The most powerful telescope ever launched into space, its greatly improved infrared resolution and sensitivity will allow it to see things that the Hubble Space Telescope cannot see because they're too old, distant, or faint. This is projected to enable a wide range of astronomical and cosmological investigations, such as observations of first stars and the development of first galaxies, as well as precise atmosphere, characterization of possibly habitable exoplanets. JWST was launched on an ESA Ariane 5 rocket from Kourou, French Guiana, on December 25, 2021, and is still being tested and aligned as of April 20th, 2022. Once operational, which is scheduled around the end of June 2022, JWST will take over as NASA's premier astrophysics mission from Hubble. JWST was developed in collaboration with the European Space Agency or ESA and the Canadian Space Agency by the National Aeronautics and Space Administration or NASA of the United States or CSA. The NASA Goddard Space Flight Center or GSFC in Maryland oversaw telescope development. The Space Telescope Science Institute in Baltimore operates JWST, and Northrop Grumman was the prime contractor. The telescope is named after NASA Administrator James E. Webb, who served from 1961 to 1968 during the Mercury, Gemini, and Apollo programs. COBE, WMAP, and Planck have all seen further back than JWST, while JWST will view further back than Hubble. JWST was planned to see a time of the universe's history that no one has seen previously, rather than the start of the universe. What we can see are the first objects that appeared as the universe cooled following the Big Bang. That time period is likely hundreds of millions of years later than the one for which COBE, WMAP, and Planck were designed. It's believed that the tiny temperature waves they detected were the seeds that grew into galaxies. It's unknown when or how the universe created the first stars and galaxies. That is why scientists are developing JWST to assist in answering this question. We will only be able to see back in time to when these items were developing if we look extremely far away. Hubble isn't big enough or cold enough to detect the faint heat signals of these distant objects. Life's chemical elements were created in the first generation of stars after the Big Bang. We're all here today because of them, and scientists are trying to know how it happened. The first stars must have influenced our own history in some way, beginning with stirring everything up and forming the other chemical elements besides hydrogen and helium. So if we truly want to understand where our atoms came from and how the little planet Earth became capable of supporting life, we must first measure what happened in the beginning. And that's all for today's video. Thanks for watching. If you enjoyed this video, then do like, share, and subscribe to our channel for more such exciting content.